So hi everyone, today is 11th of January 2023 and I welcome you all to my channel. Today we are again going to discuss about the daily question of the LeetCode, which is the minimum time to collect all apples in a tree. Now initially when you look at this question you will feel like it's a tree question, okay, but it's not. It's more of a graph kind of a question, and we have to do it in that format because the examples that are given are seems like it is a kind of a tree. Okay, so let me just first introduce you what's the question. Okay, so given an undirected tree consisting of n vertices number from 0 to n minus 1, which has some apples in their vertices. Okay, so we have apples on the vertices, right? You spend 1 second to walk over one edge of a tree. Return the minimum time in seconds you have to spend to collect all the apples in the tree. So basically I'll explain you what's the question. So in this question we have given this undirected tree, and at some edges, okay, at some vertices, uh, we have given apples. There can be apple or there cannot be an apple on a vertices. So how can we determine that? We have this has apple I, which is an array, and it will tell you that whether the vertices that is given contains an apple or not. Okay, so I hope you get the point. So we have given this edge in a 2D vector format, and for example 0 and 1 and 0 and 2. So 0 is connected with 1 and 0 is connected with 2, then 1 is connected with 4 and 1 is connected with 5, 2 is connected with 3 and 2 is connected with 6, and has apple false the true, which means at this point it is true, at this point, sorry, and false, then true, then false. Okay, so in this format it is given. This has apple array is been given. Okay, so we have to return the output should be like the path that we are traveling. So you can see that to grab these two apples we have to go from here to here, then here to here, and then to come back, and then from 1 we have to go to 5, grab the apple, we have to go back, from 1 we have to go back, and then we have to travel this side and then come back. Okay, so we can do in this manner also, that from 0 to 2 we'll go here, and then from 2 we'll go back and then travel 1, then 4, then 5, then go back and then go to 0. So either way is possible. So we are going to discuss this question. For that, let's just go to the Scali-draw. Okay, so what we'll do is you guys are able to see that whether I'm traveling the I have to travel the whole tree. Okay, that the tree that is being made, I have to travel whole, because I don't know, like how can I know ki, whether the parent will sorry, the child will return me apple or not, like which part to take. Okay, so I hope you are getting the point. So what I'll do is, you are looking at this, like if I'll go to this one, okay, so I'm traveling this side, I'll go to this one, then again I'll ask the children, do you have any apple? So the will proceed to 4. After going to 4, it will ask whether you are having child, and like the 4 will ask his child that you are having apples or not. So we'll go here, okay, and we'll go here, like but there is no child, so it will return 0. Okay, so 0 is being written from here and 0 is being written from this side. So after returning 0 from both the side, this will say like I am having an apple, okay, so take that apple. So this will return what? This will return 1. But as you know that I am coming to this and going back to this, so what should be that answer? We'll have to add 2. Okay, so every time at the answer we'll add 2, because we are coming at this vertex and vertices, and like we are going back, so it will return 2 to this 1. Okay, and after going to this 1, we'll say to 5 like whether you are having apple or not. It will tell, okay, let me confirm to my child first. It will go to his child, like left and right child, left and right child. Okay, and they'll both return 0 and 0, but it will say like I am having an apple, so please take my apples. So this will also return 2. Why? Because coming back and going back. So you can see that these arrows are depicting the number of answers. For example, 1 2 3 4 5 6 7 8. 8 arrows means the answer. Okay, so what this will return? 1 will return 2 plus 2, which is 4, and 4 plus 2, 6. Okay, so every time at the answer when you are reaching, okay, so you have to add 2 to the answer. Okay, so this 1 will return 6 here. After returning to this, we'll travel this 2. Okay, we'll travel this 2. This 2 will say like, let me ask my children. It will ask 3. 3 now, no, so 0 0, it will return 0. Okay, here also it will ask 6 also, so 0 0, and it will return 0. Okay, so here also we will get 0. So after returning 0 0 from both the sides, what will happen is that when this will encounter, then what it will return, it will return 2. Okay, so it will return 2. Now 6 plus 2 equal to 8. So 8 is our answer. So I hope you get the question what I'm trying to say. Let me go back and uh, let me just do it with this example also. Okay, so let me just go back and copy that image and go back here and paste it. Okay, control V, right. So let's do with this example to for the understanding purposes. So we have this undirected tree, you can say. Now after going from 0 to 1, okay, we'll ask 1 that whether you are having apple, so it will go to 4. 4 will say let me ask my child. So the child of 4 will return 0 and 0, 0 and 0, and this, so this 4 will return 0. So no need to travel this. Okay, so we don't have to travel this node. Now 1 will ask is 5, so 5 will say okay, let me ask my children. So this will return 0 0, but it will say like you can see like I am having apples, so you please take those apples and please add answer, like make the answer plus equal to 2, like add 2 to the answer. Okay, so after after coming from 5, this will say okay, I'll return something to 0 this node. What it will return? Answer plus 2, because already we have to travel to this node to take the apple, so this will return 4. After going from there from 0 to 2, it will say like please let me check my children first. So the children of 3 will be checked first, like okay, so this will return 0 0, so 0 will be returned. And similarly 6 6, so they'll say like 0 and 0, and it will also return 0 from here. So what he'll say, he'll say like okay, I am having apple, take the apples and please travel it. Okay, so the what is the minimum, like 2 steps, 2 minutes are being required coming back and going back. Okay, so 4 5 6, 6 is the answer, and you can clearly see in this 6 is the output. So this is what the question is saying, and I hope you get the approach. Let me just verify like what is the code is saying, and I'll explain you the code. First of all, I'm creating a adjacency list. So what is the adjacency list kind of a thing? Basically like 0, let me explain you. 0 is adjacent, like the element is connected with 1 and 1 is connected with 0, this kind of a thing. Okay, or you can say that 0 is connected with 1 and 1 is connected with 4 and 5 and again with 0. So you can say that maximum one element of one vertices is connected with 3 vertices, 1 2 and 3. Okay, so this vertices is connected with this one 4, this 5 1, and this 0. So this kind of a thing I am going to make with the help of adjacency list. Okay, so I have defined an adjacency list which is a vector of vector int. Okay, and inside that I am like traveling the edges, and in that a of x0, okay, we have to push back x of 1. Okay, so kind of an arrow you can say that I have made and explained to you. After making this adjacency list, what I have to do, I have to return the DFS. So what is the DFS? Basically traveling method that I have told you. So it's a depth first search. Okay, so we are going into depth and then searching it and then coming back. Okay, so in the depth manner it is going to work. So what I am going to have, like what I am returning and what I am calling from this DFS, -1 which is the previous. Okay, so I have defined the previous variable, then current, which is 0, the starting point, then A, which is a vector which is adjacency list that I have just made, and then has apple, the array which will tell me that whether it is having an apple or not. Okay, so after going into this DFS function, what I'll have to make first of all the answer to be 0. Okay, so I'll apply the for loop, and inside that uh, this is the x which is traveling and a current basically into that adjacency list. And then what is happening, if my x is what, x is basically this one. Okay, so this a is current values. So if it is not equals to the previous one, so what you will do, please store the result, please store into the result what, again call the DFS recursively. It will call the DFS recursively, and what it will make, it will make the current to be the previous. Basically the previous is now current, and current is now x. Okay, and a is, you know, adjacency list and has apple like as it is. So after traveling to this, like it will travel in a DFS manner, it will come to 4 for example in this case, and it will check whether the result is greater than 0 or has apple is true. Okay, so based on that, so nothing is true, basically result of apple is not greater than 0 because this is returning 0. So the result will be again the 0, as you guess. But if for example if I am coming to this part 5, then what it will say, it will say like, is this greater than 0, but will not find that the result is greater than 0 in this case first of all, but we'll see that has apple is true. So what we'll do, we'll make answer press is equals to result plus 2. What is the value of result? We'll add 2 into it. Okay, so answer plus is equals to result plus 2. Okay, not the answer plus 2, result plus 2. So I hope you get the point, and this is the question, and after that, after traveling all these things, after doing this, we have to return the answer. So I hope you get the question, and if you like this, please subscribe the channel. We'll meet tomorrow again. Thank you. Bye.